Hi, it's Mrs. Pope, and today we're going to talk about the end behavior of a graph. What that means is what happens to the graph on its ends. So where does the graph go? The goal is to describe this end behavior and determine the degree just by looking at a graph. So vocab end behavior, as I said, describes the behavior of the graph as x approaches positive infinity, that's our infinity sign, and as x approaches negative infinity. So as you travel all the way to the right, that will be positive infinity. What happens to the graph? And if you travel all the way to the left, that will be negative infinity. So the way you would write them, this is standard. You can write this down every single time you're asked to describe end behavior. This is what you'll need. You'll need to state, as x approaches positive infinity. So notice this is positive infinity, because if I just kept going on and on and on and on and on, it would continue. This would be negative infinity. So as I'm traveling to the right for this graph, what ends up happening? Where does it end up going? Well, the graph ends up going also to positive infinity, because of course up here would be positive infinity as well. Now, as x travels to negative infinity, so as I'm going along the graph to the left, to the left, to the left, to the left, what ends up happening? This one also ends up going to positive infinity. So this is how you would describe the end behavior of a graph. As x approaches positive infinity, the graph approaches positive infinity. As x approaches negative infinity, the graph or the function also approaches positive infinity. Now let's look over here. As x approaches positive infinity, so as we travel to the right, what's happening to the graph? Of course, it's heading toward negative infinity. As x approaches negative infinity, so if I'm traveling to the left, because I'm heading toward negative infinity, my x values, then of course this graph also is approaching negative infinity. So this describes the end behavior, and this is exactly how you'll have to write it. Let's look at a couple of graphs that you should know the shapes of. So here we have cubic graph, and notice here we talk about the end behavior as x approaches positive infinity. So if I'm traveling up to the right, well, of course, the graph is approaching positive infinity. And as x approaches negative infinity, so as I travel to the left, the graph f of x approaches negative infinity. All right, let's look at the other example of a cubic function. As x approaches positive infinity, so as I'm traveling to the right all the way, this is approaching negative infinity. And as x approaches negative infinity, so as I'm traveling to the left, my hand on the graph is going up toward positive infinity. So that describes the end behavior. Let's look at some generalizations. So even degree polynomials, meaning the highest degree is even, so it'll be 2, 4, 6, 8, whatever it is. If you have even degree polynomials, you either could have something like this where there are no zeros, or here we have 4 zeros. And in general, you're always going to have either an even number of zeros or no zeros. So we'll always have an even number of zeros. Let's call those real zeros, or no real zeros. And remember, zeros are the same as roots whenever they cross the x-axis. And I want you to notice the end behavior. So the end behavior of these even function degrees, notice they're either both going down or they're both going up. So that's something that's unique about even degree polynomials. So even just by looking at a function, I don't care how many times it swirls in the middle, if the end behaviors both end up going in the same direction, whether they're both up or they're both down, that means that this is an even degree polynomial. So keep that in mind about the end behavior. Now look at the odd degree polynomials. So here we have 1, 0. Notice it crosses one time. 1, 2, 3. Here we have 3 zeros. And there are other options, but you will always have an odd number of zeros. When you're dealing with odd number of real zeros, when you're dealing with an odd degree polynomial. And also notice the end behavior. All right, so notice these, they go in opposite ends. This one's going up, this one's going down. This one's going up, this one's going down. So you know that a polynomial is an odd degree or has a degree of an odd number if the end behaviors are in fact going in the opposite direction. So here's our example. Let's try it out, all that we just learned. Describe the end behavior. Then I want you to tell me, is it an odd or even degree? And what are the number of zeros that we have here? So first, describe the end behavior. You have to start writing out the way we write it out. As x approaches positive infinity, f of x approaches what? As x approaches negative infinity, the graph approaches what? So as we travel to the right, all the way toward positive infinity, this graph ends up at negative infinity. And as we travel to the left toward negative infinity, so I'm traveling to the left, to the left, to the left, this ends up at positive infinity. So I described the end behavior. Is it odd or even? You should know already it's odd because the end behaviors are going in opposite directions. So this is an odd degree polynomial. I don't know what the degree is, but it's odd. It's definitely not an even number. And what was the other thing? The number of zeros. Well, how many times does it cross the x-axis? 3, 4, 5. So we have 5 real zeros. So it actually crosses the x-axis 5 different times. Odd degree because of the opposite ends. All right, thanks for watching, and remember you are responsible for your own learning.